Welcome pre-cal students to the homework help video, page 647, number 7 through 37 Let's jump into this right away and get started. Number 7. Notice on number 7 through 15 there's no domain given like this, 0 to 2 pi. Okay? So on these problems here we do have to be sure and add 2 in pi to all of these. Okay? And here we go. Number 2. 2 cosine x plus 1. This is a pretty simple trig equation. The first thing we're going to do is we're going to isolate the cosine. So we're going to bring the 1 over and make it negative, and then divide both sides by 2. So you should end up with this right here, negative 1/2. So we're looking for an angle in which when you take the cosine of it, you get a negative answer out. So cosine is negative here, and cosine is negative here, quadrant 2 and quadrant 3. Alright, so here we go. Let's see what angle, when you take the cosine of it, gives you 1/2, okay? Here we go. Cosine, here it is. Cosine of 60 is 1/2. There we go. So, we're going to put 60 in this triangle and 60 here. And we're going to start on the positive x-axis and go to here. So one answer is 120. And we're going to start here and go 180 plus 64, the other, or 60 more. The answer would be 240. And so we convert those over to radians, and what we should get will be, give your old teacher just a second here, you should get 2 pi over 3 plus 2 n pi, and you should also get 4 pi over 3 plus 2 n pi. Now students, remember, I do want these answers in radians, number 1. And number 2, remember, you only check your answers when you have 2 different trig functions at the start of the problem, or if you've squared both sides. Okay, and neither one of those situations took place, so we do not need to check our answers. Okay, number 9, here we go. Okay, we're going to isolate the cosecant, so we're going to bring the negative 2 over and make it a positive 2, and then divide both sides by square root of 3. So here we go. Cosecant of x equals 2 divided by square root of 3. Now we should rationalize the denominator real quick just to get a better idea of what we're dealing with. So the cosecant of x equals 2 square root of 3 over 3. Well, let's see. First of all, cosecant, what we're looking for is an angle that when you take the cosecant of that angle, you get out a positive answer. So cosecant is positive where sine is positive, because sine and cosecant are reciprocal identities or reciprocal functions. So let's see, sine is positive here and sine is positive here. So there's our 2 quadrants. And now let's see if we can't find an angle that when we take the cosecant of it, we get 2 square root of 3 over 3. Here we go. Right here, cosecant of 60 is 2 square root of 3 over 3. So 60 is the angle we will put inside the triangle. Okay, so here we go. 60 here and 60 here. If you like to use radians, it would be pi over 3 and pi over 3. Okay, well, here we go. We're going to start right here on the positive x-axis and go to the hypotenuse. So one answer would be 60. And then we're going to start on the positive x-axis here, and we're going to go to the hypotenuse. So we're 60 short of 120, or 180, which would be 120 degrees. All right, so our answers should be, let's see, 2 pi over 3, and that would be for down here for 120 degrees. Sorry about that. 2 pi over 3 plus 2 n pi, and then for 60 it would be pi over 3 plus 2 n pi. Okay, there's your answers. I keep pausing, students, just so you know, so I can check the back of the book and make sure I have the right answers, and that's why it takes a second. Okay, we're good. Those answers are correct. Let's go ahead and take a look at number 11. Okay, still not too difficult. We have a secant right here. and we're going to isolate the secant, so we're going to bring the 4 over and make it a positive 4. Then we're going to divide by 3, and then we're going to take the square root of both sides. So here we go. Secant squared x equals a positive 4/3, and then take the square root of both sides. The square root of secant squared would be secant, and the square root of 4/3 plus minus, well, the square root of 4 is 2, and the square root of 3 we don't know, so we'll leave it square root of 3. Now we're going to rationalize this, so we really get plus minus plus minus 2 square root of 3 over 3. So first notice that because we have plus minus, that means we're looking for an angle that when you take the secant of that angle, you get out a positive answer and you get out a negative answer. So in that case, we're looking for the quadrants where secant is positive and where secant is negative. Well, secant is a reciprocal identity of cosine, and so the same signs for cosine will apply to secant. So where is cosine positive? Well, cosine is positive here and here. And where is cosine negative? Well, cosine is negative here and here. So there we go. Let's go ahead and pull up our table here and see if we can find an angle in which when you take the secant of it, you get 2 square root of 3 over 3. And it looks like it's right here. Secant of 30 is 2 square root of 3 over 3. So there we go. All right. So let's put a 30 here, and a 30 here, and a 30 here, and a 30 here. Or, if you want to deal with radians, you can put pi over 6 instead of 30, okay? And here we go. We'll start here and go to the hypotenuse. So one answer will be 30 degrees. And then we start here and go to the hypotenuse. We're 30 degrees short of 180, so 150. Then we'll start here and we'll go 180 plus 30 more, that's 210 degrees. And then we'll start here and go all the way around to this hypotenuse. We're 30 degrees short of 360, so 330. Now let's quickly convert all of these to radians. 30 degrees, of course, is pi over 6. 150 would be 5 pi over 6. 210 would be 7 pi over 6. And 330 would be 1 and 5/6, so 11 pi over 6. And then, of course, each of these have to be added to it, 2 and pi. And you're welcome to use ditto marks. I have no problem with that. And there's our answer right there. And let me quickly check the back of the book here and make sure that we're on target here. Pi over 6, 5 pi over 6. Yep, we're totally good. Moving on to number 13. Okay, now notice on 13, it's already factored for us. It would be very similar, students, to in Algebra 2, having a problem where you had x, and then x plus 1 already set equal to 0. Well, you would take x, set it equal to 0. You would take this group here and set it equal to 0. Okay, so the same thing here applies. We have a group times a group set equal to 0. Okay, so I'm going to take my first group here, sine of x, and set that equal to 0. And then take my second group, sine of x plus 1, and set that equal to 0. Now, students, notice something here. Please don't miss this, students. Notice it's not sine of x plus 1 in parentheses. Okay, it's the sine of angle angle x, then plus 1. Okay, so be very careful. Let's start over here first. Sine of x equals 0. Now that's going to be one of our quadrant angles. So I'm very quickly going to type in the sine of 0. And that did give me 0, so there's one answer. And the sine of 90, and that did not give me 0. Sine of 180, that did give me 0, so there's another answer. And then the sine of 270, which did not work, and we're not going to worry about 360. Now let's come over here. Let's bring the 1 over and make it a negative 1. And once again, anytime you're looking for an angle that when you take the sine of it, you get 1 or -1, you are looking for one of your axis angles or quadrant angles. So again, I'm going to try 0. I'm not going to try 0 because I know from over here the sine of 0 is 0. And I'm not going to try 180 because I know from over here the sine of 180 is 0. I will try 90. The sine of 90 is 1. It's not going to work. I will try 270. The sine of 270 is -1. So there we go. So there's our 3 answers. And now let's write them with radians. So 0 degrees is 0 radians plus 2 n pi. 180 would be pi radians plus 2 n pi. And 270 would be 3 pi over 2 plus 2 n pi. Okay, let me very quickly check the answer key and we'll go on. And let's see what we got here. Yes, we're totally good. Moving on to number 15. Okay, students, this problem here should look very familiar to this problem back here, where we got secant squared by itself, and then we took the square root of both sides. Okay, so back over here, number 15, same thing. We're going to get cosine squared by itself, and then we're going to take the square root of both sides. So here we go. Cosine squared x equals, bring the 1 over and make it positive, then divide by 4, you get 1/4. And now we'll take the square root of both sides. So the square root of cosine squared is cosine. And the square root of 1 is 1, and the square root of 4 is 2, plus minus. Now students, as soon as you see the plus minus right here, you should realize right away we're looking at all 4 quadrants, because cosine is positive in 2 quadrants and cosine is negative in 2 quadrants. Okay, so we know that we're going to be using all 4 quadrants. Okay, now the question is what angle do I want that when I take the cosine of that angle I get 1/2? Okay, so let's figure it out here. Cosine of 60 is 1/2, so there it is. Okay, so we'll put a 60 here, a 60 here, a 60 here, a 60 here. If you want to put pi over 3 instead, you're welcome to do that. And here we go. We'll start here and go here. It's 60 degrees. Then we'll start here and go here, and that's 120 degrees. And then we'll start here and go 180 plus 60 more would be 240 degrees. And then we'll start here and we'll go 300. We're 60 short of 360, so we'll go 300 degrees. So 300, and there's our 4 answers. Now let's quickly convert all these over to radians. 60 would be pi over 3 plus 2 n pi. 120 would be 2 pi over 3 plus 2 n pi. 240 will be 1 1/3, so 4 pi over 3 plus 2 n pi, and this would be 1 2/3, so 5 pi over 3 plus 2 n pi. Okay, and let me very quickly check the back of the book here for number 15. And let's see what we have here. Pi over 3, and we are good. Moving on to number 17. Now notice in your book, students, numbers 17 through 27 have a domain 0 to 2 pi. Okay, so on these problems here, we're not going to use plus 2 n pi. We're just going to find all the answers that exist between 0 and 2 pi. Okay, and that's for numbers 17 through 27. Okay, so here we go. Number 17. Now students, as soon as I see this problem here, I say to myself, you know, I've got a cosine cube and a cosine x over here. Now, if I was taking Algebra 2 class and I had x cubed equals x, I would bring the x over, so the right side is equal to 0. That would factor out an x like that. And then I would take each group and set each group equal to 0, okay? And that's what we're going to do here. So here we go. The exact same principle applies here, okay? Let's go ahead and take cosine cubed minus cosine, and that equals 0, okay? Then we're going to factor out a cosine. And when you pull it out, you're left with cosine squared x minus 1. And then students, to be honest with you, you could factor this again right here, because you know the square root of cosine squared and you know the square root of 1, so you really have the difference of two squares. Or you can just take this group here, set it equal to 0, and solve. That's what I'm going to do. Okay, so I'm going to take cosine x. And either way, you would get the right answer. I'm going to take cosine x, set it equal to 0, and then take cosine squared x minus 1 and set it equal to 0. Okay, now, obviously over here on this part of the equation here, we're looking for an angle that when you take the cosine of it, you get 0. That's going to be one of our quadrant angles. So cosine of 0 does not give you 0. Cosine of 90 does. So there's one answer. Cosine of 180 does not give you 0. Cosine of 270 does. So there's another answer for us. Now, cosine squared equals 1. I would bring the 1 over and make it a positive 1. Then take the square root of both sides, so the square root of cosine squared is cosine. And the square root of 1 will be plus minus 1. Don't forget the plus minus, okay? So, we're looking for angles that when I take the cosine of that angle, I get positive or negative 1. So, that's going to be, once again, a quadrant angle. So, here we go. Cosine of 0 gives me 1, so that works. Cosine of 90 gives me 0, that doesn't work. Cosine of 180 gives me negative 1, so that works. And cosine of 270 gives me 0. So I'm looking at 0 and 180. So 0 works and 180. So I have 4 answers, 1, 2, 3, 4. I'm going to quickly convert these over to radians. 0 degrees would be 0 radians. And I was getting ready to put plus 2 in pi, but to be honest with you, remember this problem here has a domain going from 0 to 2 pi, okay? So with that in mind, I want all of the answers that fall in this region. So 0, 90 is pi over 2, 180, which is pi, 270, which is 3 pi over 2. Okay, let me check number 17 real quick here and see if we got those answers correct. Pi over 2, 3 pi over 2, 0, and pi. Yes, we did, okay? So we're good. Moving on to number 19, all right? Number 19, here we go. All right, kind of the same thing. Again, students, if I was in an algebra class, and I saw a problem like this, 3x cubed equals x, I would bring the x over and make it a negative x, okay? And then pull out an x, and I'd be left with 3x squared minus 1 equals 0. Then I would take each group and set each group equal to 0, okay? Well, the same thing applies here. I'm going to bring the tangent over. And then factor out a tangent. So I'm left with this right here, okay? Now take each group and set each group equal to 0. So tangent x equals 0, and then 3 tangent squared x minus 1 equals 0. Well, this one over here already has tangent isolated, so we're trying to find angles so that when I take the tangent of it, I get 0. So let's say it's going to be one of my quadrant angles. So tangent of 0 is 0. Tangent of 90 does not does not work. Tangent of 180 works. So 0 and 180 so far work. Tangent of 270 does not work. So we have 0 and 180 so far. Now let's come over here and get tangent by itself. So I would have tangent squared x equals, bring the 1 over and make it positive, and then divide both sides by 3 to get 1/3. Now take the square root of both sides. The square root of tangent squared is tangent. Square root of 1 is 1. Square root of 3 is square root of 3. Plus, minus. Okay, now let's rationalize this side over here. So plus, minus, square root of 3 over 3 like this. And so here we go. Notice we want to find an angle that when I take the angle, the tangent of that angle, I get a positive or negative square root of 3 over 3. So I'm dealing with all 4 quadrants, okay? So I've got to find the 4 answers that when I take the tangent of that angle, I get square root of 3 over 3 positive or negative. Now we're probably going to need our table here. So here's our table. And let's see, tangent square root of 3 over 3. Here it is right here. The tangent of 30 is square root of 3 over 3, okay? So students, I'm going to put a 30 here, 30 here, 30 here, and 30 here. Or if you want to put pi over 6, that's fine. Okay, now we're going to start right here and rotate up. We're going to get 30 for one answer. Then we'll start here and rotate to the hypotenuse. That gives us 150 for an answer. Then start here and go 180 plus 30 more, so 210 degrees. And then start here and go all the way to the hypotenuse here, which is 30 degrees short of 360. So we're looking at 330 degrees. So really, what we have, students, is 4 different answers. 1, 2, 3, 4, 5, 6. Okay, now we need, notice all of those do fall in our domain of 0 to 2 pi or 0 to 360 degrees. So the last thing left to do is simply convert these over to radians, okay? So let's see if we can't convert these over to radians. And here we go. 0 would be 0 radians, 180 would be pi. So there's 2 answers. 30 would be pi over 6. 150 would be 5 pi over 6. 210 would be 1 and 1/6, so 7 pi over 6. And 330 would be 1 and 5/6, so 11 pi over 6. And let's see how our answers lined up quickly here. Everything looks good. Okay, moving on to number 21. Number 21. Now, when I look at this left side over here, students, I realize, hey, I could factor out a secant and be left with secant x minus 1, okay? But that's not going to work because the right side is not equal to 0. It really doesn't do a lot of good to factor if the right side is not equal to 0. Okay, students, you need to understand that. So what I'm going to have to do here is bring the 2 over and make it negative so that the right side is equal to 0. And now let's try to factor this and see what happens. I would encourage you to rewrite this like it's an algebra expression. So x squared minus x minus 2. And if you were to factor that, you would get, and again, we covered this the first week of school, students. So x negative 2, x positive 1, because negative 2 times 1 is negative 2. If you combine negative 2 and 1, you get a negative 1. So the last thing left to do is put secant secant back in. So I have secant x minus 2, and this secant x plus 1. All of that equals 0, okay? So let's get rid of this, get some space going here. And here we go. Let's take our first group here and set it equal to 0. Let's take our second group here and set it equal to 0. Here we go. Bring the negative 2 over and make it positive. Now we're looking for angles that when we take the secant of those angles, we get 2. And let's see what we can come up with here. Let's see. Look at our list here. Okay, secant of 60 is 2, okay? So we know we're dealing with a positive 2. So secant is positive where cosine is positive, so cosine is positive here and here. Okay, so there we go. And what did we say it was? 60, I believe. So we'll put a 60 here, or pi over 3 and put a 60 here. So we're going to rotate from the x-axis to the hypotenuse. That's 60. That's one answer. And then from the x-axis to the hypotenuse, that's 300. So there's 2 answers right there, okay? Now let's go ahead and solve this equation over here. So secant x equals negative 1. Now students, since we don't have secant on our calculator, I would encourage you to take secant and rewrite it like this. I would rewrite it so that it says cosine of x, and then cosine and secant are reciprocals. I would flip the 2 and I would put 1/2 here, okay? Now over here the same thing. For secant I would put cosine and then flip negative 1, and when you flip negative 1 you still get negative 1, okay? Alright, now let's do cosine of x equals negative 1 first. That should be pretty simple to do, students. Here we go. Let's see, cosine of 0 does not give me negative 1. Cosine of 90 does not give me negative 1. Cosine of 180 does give me negative 1. Cosine of 270 does not. So we're looking at 180 degrees. Now, we're trying to find an angle that when we take the cosine of it, we get positive 1/2. And of course, that's going to be cosine is positive here, and cosine is positive here. So let's see if we have an angle we can work with here. Let's see here. Okay, cosine of 60 is 1/2, okay? So we're going to put 60 in here, and 60 in here, which is pi over 3 if you prefer, that's fine. And here we go. We're going to start right here and go to the hypotenuse, so 60 is one answer. Then we'll start right here and go to the hypotenuse, which would be 300 degrees. So here's our 3 answers right here, students. We have to convert those over to radians very quickly, so here we go. In radians, 180 would be pi, and in 60 it would be pi over 3, and in 300 it would be 1 2/3, which is 5 pi over 3. So there's your answers that fall between 0 and 2 pi, okay? And let me check the back of the book real quick. We're going to make sure we're accurate on this. Pi over 3, pi, and 5 pi over 3. Yes, that's correct. Moving on to number 23. Okay, students, number 23. 23, notice we have a 2 sine x and then a cosecant x. Now what we're going to have to do here is we're either going to have to try to factor if both of these terms had a sine in it, then we could factor out a sine. Okay, but that's not the case. We have a sine and a cosecant, so we're going to have to make a substitution so that we have all of the same trig functions in here. Now, obviously, the first thing that comes to mind for me is the fact that cosecant and sine are reciprocal functions of each other. So, the first thing I'm thinking of is this. Okay, now next, what I'm thinking is this. What I can do here is find a common denominator and put these two together. So I'm going to put this over 1 like that, and now watch what I do. I want to get a common denominator, so I multiply the top and the bottom of this fraction by sine and sine, and when I do that I get this. I get 2 sine squared x, okay, plus, or excuse me, 2 sine squared x over sine plus 1 over sine x, okay, which is the exact same thing as 2 sine squared x plus 1 all over sine x. Now from here, students, you should know what to do. We have a fraction that has sine in the denominator, so I'm going to multiply both sides by sine to get rid of my fraction, okay? Now listen, anytime you multiply an equation by an unknown, sometimes you can gain answers that shouldn't be there, okay? So, always be aware of that. For example, if I had an algebraic expression x squared over x equals whatever, 3, and I multiplied both sides by x to get rid of this fraction, I would have x squared equals 3x, okay? If you went ahead and brought the 3x over and factored and solved, you would come up with trust me, you would come up with an extra answer there that you're not supposed to have. So always keep that in mind. Anytime you take an equation and you multiply it by an unknown, always be careful and check your answers in the end, okay? Anyways, moving on. So I'm going to multiply both sides by sine x. So 2 sine squared x plus 1 equals, now multiply this side by sine and you get 0, because 0 times anything is 0. Now, if you get sine squared by itself, look what you end up with. Sine squared x equals negative 1/2. And you're done, you're finished. No solution. And you say, why, Mr. Earhart? Because if you go to take the square root of both sides, if you take the square root of sine squared, you get sine. And if you go to take the square root of the right side, you can't take the square root of a negative number. And so because of that, you can't solve this any further. Okay, so the answer is no solution, because there is no number at all that which you would take the sine of and then square it and get a negative 1/2. That would not happen, okay? All right, the answer is no solution. Moving on to number 25. Okay, students, on number 25, notice we have cosine squared and cosine, so we have the same trig functions all the way through. We're probably going to have to factor this, and you really should recognize this right away. It's very similar to an algebra expression that looks like this. 2x squared plus x minus 1 equals 0, okay? So I'm going to go ahead and factor it like this, and then when I'm done factoring, I'm going to go ahead and put cosine back in, okay? So 2 here times negative 1 would give me a negative 2. So I'm looking at positive 2 and negative 1. Remember, we did all this the first week, okay? So we're not going to go over this again. So 2x squared. And I did warn you we're not going to go over factoring again. So positive 2x minus 1x minus 1 equals 0. Pull out what's common in the first two terms. And you're left over with x plus 1. Pull out what's common here, a negative 1, and you're left with x plus 1. Write your matching parentheses once, and your other parentheses would be 2x minus 1. Now let's go ahead and put cosine back in. So we would have cosine x plus 1, that's one group, set equal to 0. And your other group here would be 2 cosine x minus 1 equals 0. Okay, so there we go. And let's get a little bit of space here to work with. And here we go. Let's start with our first equation over here to the left. Cosine of x plus 1 equals 0. So I would have cosine of x equals -1. Let's grab the calculator real quick here. And I think we've done these before. If I could find those real quick, I'll just go ahead and type it in. Cosine of 0 is not -1. Cosine of 90 is not -1. And cosine of 180 is. And cosine of 270 is not. So the answer here is 180. Cosine of 180 gives you -1. Now over here, let's get cosine by itself. So cosine x would be, bring the 1 over, make it positive, divide by 2, 1/2. So when does cosine give you a positive 1/2? Well, first of all, look at our table here. Cosine of 60 gives you 1/2, okay? And then, let's see here, students. Also understand cosine is positive, so we're dealing with the first quadrant and the last quadrant. So we'll put 60 here and 60 here, or pi over 3. And here we go. One answer would be 60. And the other answer would be 300, okay? So converting all these over to radians, one answer would be pi. One answer would be pi over 3. And the other answer would be 1 2/3. So 5 pi over 3 for 300 degrees. Let's check the back of the book real quick on that, make sure we're right. Pi over 3, 5 pi over 3, and pi. Very good. Moving on to number 27. Now, number 27 is the last problem here, in which we have the domain of 0 to 2 pi. Okay, so here we go. Now, notice on number 27, we have an issue here. We have a secant squared and a tangent squared. Okay, so we're going to have to make a substitution here, in which we either get rid of secant or tangent. Now, the first thing that I think of when I see this is the Pythagorean identity. And so right away for secant squared, excuse me, sorry. Okay, students, now for secant squared, I'm going to put tangent squared x plus 1, and then bring down my tangent squared x, and then bring down my -3. Now simplify, take your 2 here and multiply it through, okay? 2 times tangent squared would be 2 tangent squared. And I'm going to skip a step here, students. 2 times 1 is 2, okay? 2 times 1 is 2. And I'm going to go ahead and combine that with my -3. So positive 2 and -3 would be -1. And then bring down my tangent. Actually, I could do more simplifying here. So, and I did not see that until now. So I can also simplify a 2 tangent squared and a 1 tangent squared. And of course, that would give me 3 tangent squared x minus 1 equals 0. Now get the tangent squared x by itself. And that would leave you with 1/3. Bring the 1 over, make it positive, divide by 3. Now take the square root of both sides. Tangent squared x equals tangent x equals the square root of 1 is 1, and the square root of 3 is the square root of 3, plus minus, we have to rationalize this, so we get plus minus square root of 3 over 3. Okay, now let's get some space here real quick. And let's quickly look at our table here. Let's see, tangent of an angle gives me square root of 3 over 3. Let's see what we have here. Tangent of 30 gives me square root of 3 over 3. So we're dealing with 30 degrees here. And then also, students, we're dealing with positive and negative. So to be honest with you, we're going to be dealing with all four quadrants, okay? You can put 30 degrees in each triangle, or you can put pi over 6. Okay, so here we go. From here to here would be 30, or pi over 6. From here to here would be 150, or 5 pi over 6. From here to here would be 180 plus 30 more, so 210 degrees, or 1 and 1/6, which would be 7 pi over 6. Then from here to here would be 30 short of 360, so 330. Or we could say 1 and 5/6, so 11 pi over 6, okay? Now remember something, students. Whenever you make a substitution, whenever your original problem has two different trig functions, you really need to get into the habit of checking your answers in this original problem, because sometimes some of these answers will not work. Now in this case here, I'm looking in the back of the book, and all four of these answers do work, but on a test or a quiz, please learn to check those. I will probably give you some in which you don't have, in which you do have to check your answers, and some of them will not work, okay? So make sure you're really practicing and remembering to do that, all right? All right, moving on to number 29. Now we're getting into some good problems here where we have multiple angles, like 3x or 2x or 1/2 x. Okay, so let's be really careful here, all right? Now on these problems here, we are not given a domain like this. Okay, so we are going to have to add 2n pi to these, okay, which actually makes it a little easier, to be honest with you, in these problems. Okay, so here we go. Cosine of 2x equals 1/2. Now, what we're looking for is an angle here. I'm just going to put an arrow that when you take the angle of it, you get 1/2, okay? And it is a positive 1/2, so we are going to be dealing with the quadrants here and here. Now, next, we have to see what angle, when we take the cosine of it, gives us 1/2. So let's see, we have here cosine of 60 gives us 1/2. Okay, so we're dealing with 60 degrees. So I'm going to put 60 here, or pi over 3 is acceptable. Now watch carefully what I do here. Please, students, watch. I go from here to here, and I get 60. Now remember, we're dealing with degrees or radians. I'm going to use degrees and convert it in the very end. So now please watch this carefully, students. Watch how I do this. From here to here is 60. So this entire angle here is 60. But students, be sure and look up here. Your entire angle right here is 2x. So really what you have is not x equals 60, but you have 2x equals 60 plus, and then don't put 2n pi, put 360n, because 360 is the same thing as 2 pi, and you're dealing with degrees right now. Now divide everything by 2, and you get x equals 30 plus 180n. Now convert it over to radians, and 30 is pi over 6 plus 180 is pi, so pi n, or n pi would be acceptable. Let me check the book here real quick and make sure we're doing well. Yeah, that's exactly right. Now, here's our other answer. Remember, we have 60 here, so we start here and we go all the way around. That's 300 degrees. So this angle right here is 300 degrees. The cosine of 300 gives you 1/2. But the whole angle is 2x, so really 2x, not x. 2x equals 300 plus 2n pi, but we're going to use degrees, so 360n. Now divide both sides by 2, and x equals 150 degrees plus 180 n. Now let's write this in radians real quick. 150 over 180 would be 5 pi over 6. And of course, 180 in radians would be pi n, or n pi, okay? So there we go. There's your two answers, okay? All right, continuing on to number 31. Okay, students, here we go. Tangent of 3x equals 1. Now, usually when you see a 1 over here like this, you're thinking of quadrant angles, but tangent is the only function, or cotangent too for that matter, in which you can get out a 1, and your angle right here is not a quadrant angle. In fact, to show that to you, I'm going to pull up our table here real quick and show you what angle, when you take the tangent of it, gives you 1. And it's right here. The tangent of 45 will give you 1. And the reason that is, by the way, just so you know, just so that it makes sense, is think of your 45 degree triangle. 45, 45. Remember, these two legs here are congruent. 1, 1 is square root of 2. When you take the tangent of 45, it's opposite over adjacent, so it'd be 1 over 1. Okay, and that's why that is. So the tangent of 45 gives you 1. Now, we're dealing with a positive 1, so we're dealing with tangent here in this quadrant and here in this quadrant. These are the two quadrants where tangent is positive. So I'm going to put 45 here and 45 here. Now we're going to rotate from here to here. So one answer is 45 plus, instead of putting 2 in pi, I'm going to put, let me slide this over a little bit. Let me do this so we can see this. So we're saying the tangent of 45 equals 1. Okay, now we're going to say 45 plus, now usually we put 2 in pi, but we're going to put 360 pi or 360 in because we're dealing with degrees. And remember, this whole angle is 3x, so really x does not equal this here. 3x equals 45 degrees. Now divide everything by 3, and we get 15 plus 120 n. Now let's quickly convert this over to radians, and we will get this right here. Let me look here in the calculator. 15 degrees would be pi over 12 plus, and 120 n would be 2 pi over 3 n. Okay, so there we go. There's one answer. Now the other answer starts here. It goes 180 plus 45 more, so we have 225 degrees plus 360 n. Now that goes right here. So we're saying the tangent of 225 equals 1, which it does. If you want to try that and type it into your calculator, you will see the tangent of 225 does equal 1. Now, this is the whole angle here, 225, and this is the whole angle up here, 3x. So really 3x equals all of this. We're going to divide everything by 3 to find out what x truly equals. And x equals 75 degrees plus 120 degrees n, okay? Now we're going to convert 75 degrees to radians. And we're going to get 5 pi over 12 plus, and then convert 120 degrees to radians, and you will get 2 pi over 3 n times, okay? And there we go, okay? Now, if some of you, by the way, students, are not putting 45 degrees here, some of you, let me change colors here. Some of you might be doing this. Some of you might be saying 3x equals, and then for 45 degrees, you're putting pi over 4 plus 2 in pi, and then dividing by 3. That's totally fine. That works just great. 3x divided by 3 is x, and pi over 4 divided by 3 is pi over 12. And 2 pi divided by 3 is 2 pi over 3n. So if you want to work with radians from the very beginning and not use degrees, that's totally fine also. Either way, you will get the exact same answer, okay? All right, number 35 or 33. Here we go. Okay, now we're dealing with a half angle, okay? Cosine of x over 2 equals square root of 2 over 2. So here we go. First of all, let's get our table up here real quick. And let's pull it right here. And let's see what we have, okay? Cosine of 45 is square root of 2 over 2. So we're dealing with 45 degrees, okay? Now, the quadrants we're dealing with, when you take the cosine of x over 2, you're getting out a positive fraction. So cosine, cosine is positive here, and it's positive here. Okay, so we're going to put 45 degrees and 45 degrees. And let's go ahead and do this one, students. Let's do it all in radians the entire way through, okay? So let's just kind of see what happens here. So 45 degrees is pi over 4 and pi over 4. Okay, there we go. Now, okay, students, here we go. So pi over 4 is one answer. So I come over here and I realize that the cosine of pi over 4 equals square root of 2 over 2. Now, remember, pi over 4 equals x over 2. So really, pi over 4 does not equal x. Pi over 4 equals x over 2. So I really have x over 2 equals pi over 4 plus 2 in pi. Now, instead of dividing everything by 2, I'm going to multiply everything by 2. So multiply x over 2 by 2, I get x. Multiply pi over 4 times 2, I'll get pi over 2. And multiply 2 in pi times 2, and I'll get 4 in pi. Okay, so there's one answer right there. Now, let's go ahead and use the other triangle here. So I'm going to start here and rotate to here. So I go 1 3/4. I would get 1 3/4, 7 pi over 4. So right here I now have 7 pi over 4. So if this whole angle here is 7 pi over 4, then it equals x over 2. So x over 2 equals 7 pi over 4 plus 2 in pi. Multiply everything by 2 to get rid of your x. And you're left with 7 pi over 2 plus 4 in pi. Okay? So, and again, if you don't like that method, if you would much rather do the degrees first, that's totally fine. I just wanted to do one problem where we did radians all the way through, okay? All right, number 35. Okay, here we go. First of all, let's isolate the sine squared. And if we do that correctly, we're going to get sine squared 2x equals 1/2. Now, take the square root of both sides. So we get the sine of 2x equals, well, the square root of 1 is 1, and the square root of 2 is square root of 2. Plus minus, let's rationalize that. We'll get plus minus square root of 2 over 2. All right, so next, let's pull up our table here real quick. And what angle, when I take the sine of it, I get square root of 2 over 2. Let's see, 45. So the sine of 45 degrees is square root of 2 over 2. Okay, so here we go. And then notice, students, because I have a positive negative here, I'm dealing with all 4 quadrants. Okay, so kind of like a bow tie. All right. And 45 in all of those triangles. Okay, so here we go. Here's what we really have. We have sine of an angle equals square root of 2 over 2. So our first angle is 45. So 45 really equals 2x. So 2x equals 45 plus 360, and divide everything by 2. X equals 22.5 degrees plus 180n. Now, students, to be honest with you, on this one right here, and I'm looking at how they wrote it in the book here to make sure we get this right. If you take 22.5 degrees and convert that over to radians, you'll see that you will get out an exact number. You'll get pi over 8 plus, and then of course 180n would be pi n. Okay, so there's one answer. Now, we go from here to here, and that's going to be, let's see, 135 degrees, so we have 2x equals, and I better put up some dividing lines here so it's not confusing. Okay, 2x equals 135 degrees plus 3/6n, and divide everything by 2, and you will get 67.5 degrees plus 180n. And if you take 67.5 degrees and convert that to radians, you actually get an exact fraction. You get 3 pi over 8. All right, so x equals 3 pi over 8 plus pi n, or n pi. Okay, we're going to run out of room here, so we're going to put some dividers here and here. Okay, and continuing on. Now, here's 45 degrees here, so we're going to go 180 plus 45 more would be 225 degrees. So 2x equals 225 degrees plus 360, and divide everything by 2, and you get 112.5 plus 180n. Convert the 112.5 to radians, and you will get 5 pi over 8 plus pi n. Okay, there we go, because 180 is pi radians, right? And then lastly, we have our 45 degrees right here, so we go all the way around, 45 degrees short, and you're left with 315 degrees. Okay, students, what we have here is 2x equals 315 degrees plus 360n. Divide everything by 2, and x equals 157.5. I believe I did that in my head. I hope that's right. Degrees plus 180n. And now let's convert our degrees over to radians. Excuse me. Alright, let's convert our degrees over to radians here, as I just spilt water all over the mimeopad, so give me a second here. Okay, let's see what we have here. We would have x equals 7 pi over 8 plus pi n. Okay, there we go. Alright, guys, I hope you're getting this. Okay, I know some of these can be difficult, so I hope you guys are getting this. Okay, alright, number 37. Okay, this one will be a little bit of a pain, but we'll be okay. Here we go, number 37. Actually, I better check number 35 in the book real quick and make sure that we got that right. And it looks like we did, so yes, we're doing good. Okay, number 37. And here we go. Alright, now notice it's already factored for you, so we take our first group, which is tangent of 3x equals 0. And then our second group, tangent of x minus 1 equals 0. Okay. Now over here, we're basically saying tangent of an angle gives me 0. So real quick, let's see what that is. Tangent of 0 does not give you, it does give you 0. Tangent of 90 does not. Tangent of 180 does, like I thought it would, and tangent of 270 does not. So 0 and 180 are the two angles that give you zeros. So really what we have here is 3x equals 0 plus 2n pi, sorry about that, 360 n, divide everything by 3, and x equals 0 plus 180n, 120n, and so your answer would be x equals 0 radians plus 2 pi over 3 for 120, so 2 pi over 3n. Okay? Now, notice there's another answer that gives you 0, and that's what tangent is 180. So we're also going to say 3x equals 180 plus 360 and divide everything by 3, and we get 60 plus 120n, so x equals pi over 3 for 60 degrees plus 2 pi over 3n. Okay, so there we go. There we go. So these two answers here that I just circled are the answers for this part of the problem right here. Okay, now we're going to solve this part here. So here we go. Put a little line up here. And here we go. Tangent of x equals 1. So that's going to be pretty simple. Notice your angle here is not a 2x or a 3x or a x over 2 or anything like that. It's pretty simple, standard. So what angle gives you 1 when you take the tangent of it? Well, 45 degrees. So we're dealing with tangent's positive here, tangent's positive here. So 45 degrees here, 45 degrees here. So we go from here to here. One answer would be 45, which is pi over 4, plus 2n pi. And then the next answer would be x equals, and we start here, 180 plus 45 more is 225 degrees, which is 5 pi over 4 plus 2n pi. Okay? So there we go. Let me check the back of the book here real quick, make sure we're correct here. Let's see, n pi over 3. Yep, that works. And pi over 4 plus n pi. Yep, that is correct. So, I hope this homework video has been a help to you guys. Please understand how to do these problems very well. Work them out. Make sure that you understand this material okay. And if you have any questions at all, don't hesitate to call or email.